G'day guys, we've got a projectile motion question today where we have a tennis ball that's hit close to the ground at a velocity of about 30 meters per second at an angle of 25 degrees to the horizontal. We're asked to find the vertical and horizontal components of the ball's motion. We're asked to also find the maximum height the ball reaches, the time of the ball's flight, and the distance that the ball goes, or the horizontal range. So let's get straight into it. To start with, when finding the initial vertical and horizontal components of the ball's velocity, we're going to need to understand that in two dimensions, like this question is, any vector is going to be able to be made up of two component vectors. So what we're going to do is we're going to draw a triangle, or a vector triangle, that's going to be able to relate the horizontal and the vertical vectors to the initial 30 meters per second, 25 degrees to the horizontal ball trajectory. Okay, here's our vector triangle. Now as you can see, we have our initial 30 meters per second velocity at the angle of 25 degrees to the horizontal. Now what we can do is, using this angle and this velocity here, we can use trigonometric ratios to find the initial velocity in the vertical direction and the initial velocity in the horizontal direction. Okay, so let's start with the vertical direction. So what we have here is that the vertical side on this vector triangle is the opposite to the angle. The trigonometric ratio which relates the opposite and the hypotenuse is sine. So what we have is, using sine, we can go, the sine of any angle is equal to the opposite side divided by the hypotenuse. So what we can do is we can rearrange this to say that the opposite side, which is what we need, is equal to the hypotenuse multiplied by the sine of the angle. So what we can then, as a result, we can say that this is the hypotenuse, 30, multiplied by the sine of the angle. And that there is going to be 12.68 meters per second, which we'd expect that to be smaller than this. Both of these components will have to be smaller than the hypotenuse. Okay, so the trigonometric ratio, which relates the adjacent side, this side, to the hypotenuse, is cosine. So what we have is we can have the cosine of any angle is equal to the adjacent divided by the hypotenuse. Okay. Again, using a bit of algebra, we can say that the adjacent side would be equal to the hypotenuse times the cosine of the angle. And in this case, the hypotenuse is 30 times the cosine of 25 degrees gives us, I'll just write it down here, a initial horizontal velocity of 27.19 meters per second. Okay, so that's the answer to part A under control. We have our horizontal and our vertical components of the ball's initial velocity. Okay, now on to part B. Now the first thing that we're going to have to understand to figure out the maximum height that the ball reaches is that the velocity in the vertical direction at the maximum height is equal to 0. So what happens is, as the ball goes up, it's decelerated by gravity, and until it reaches a point at the maximum height where its vertical component of its velocity is 0. So let's just draw a parabolic motion for a second. We have a parabola that looks like that with a maximum height here, and we are aware that the velocity in the vertical direction is equal to 0. Now the next thing that we're going to have to do to solve this question is we're going to have to find a formula that relates initial velocity, final velocity, and the displacement that the ball is going to travel. And we only really have one formula for this. And that is v squared equals u squared plus 2as. V squared being the final velocity squared, u squared being the initial velocity in the vertical direction squared, 2a being the acceleration due to gravity, and s being the displacement of the ball. Now, we know that the final velocity of this ball is going to be 0. So we have 0 squared is equal to the initial velocity of the ball in the vertical direction is 12.68 meters per second squared. Then we're going to add 2 times the acceleration due to gravity, and because it's in the opposite direction to the initial velocity of the ball, we're going to have to give it a negative value times the distance. Now, if we use a little bit of algebra, we can solve for the distance or the displacement as being 8.20 meters to 3 significant figures. So just a working knowledge of that particular formula will get you through this part of the question. Now, on to part C. The time of the ball's flight. Okay, to work this question out, what we're first going to do is we're going to work out the time that it takes the ball to get from where it's hit by the racket to the maximum height. And then we're going to use the fact that the parabolic motion, if we ignore air resistance, is symmetrical, to just multiply this time here by 2. Okay, so how are we going to do this? Well, again, we're going to make use of another one of our formulas which describe motion. So this formula is V equals U plus A T. So we have the final velocity, which in this case again is 0 at the maximum height, is equal to the initial velocity in the vertical direction, which is 12.68, plus A, which is the acceleration due to gravity, and again, because it's in the opposite direction of the initial velocity, we're going to have to give it a negative value, times the time. Now what we can then do is we can do a little bit of algebra, take the 12 over, divide by negative 9.8, and we get a time which is equal to 1.29 seconds. Now that's the time that it takes to get from where it's hit by the racket to its maximum height. However, we just identified that we have to multiply that by 2 to get the entire time of flight for the ball. So the total is going to be equal to 2t, which is equal to 2.58 seconds. Cool. Now on quickly to part D. The horizontal range. Now, one of the other key components of parabolic motion is that the velocity in the horizontal direction is constant. So if we disregard air resistance, this initial horizontal velocity component is going to carry through for the entire range of the ball. Now what's helpful to us about that is that if we have the time of flight and we have a constant average velocity, then all we have to do is employ this formula, S is equal to Vt, or average velocity times time, to get our range. So all we have to do is we have to say that our average velocity in the horizontal direction is going to be 27.19, and our time is going to be 2.58. And if we multiply those two together, we get 70.15 meters. So it's a bloody long tennis shot. Okay guys, in summing up, what I want you to take away from this projectile motion video is a couple of key points. First key point is that for any vector in 2 dimensions, it can be broken into 2 perpendicular component vectors. In this case, we have a horizontal and a vertical component vector of our ball's initial velocity. Point 2 is that the maximum height of the ball will also correspond to when the vertical component of the ball's velocity is 0. We found that out in part B of the question. Point 3, that because parabolic motion, if we ignore air resistance, is symmetrical, we can just work out the time by working out the time it takes to get from the bottom of our parabola to the maximum height and then multiplying it by 2. And the last thing, guys, is that if you have a good knowledge of our formulas of motion, and they are formulas like v squared equals u squared plus 2as, s equals ut plus half at squared, v equals u plus at, and if you like, s equals average velocity times time. If you have a good working knowledge of all of those, then you shouldn't have any problem in nutting out any projectile motion question you're given. So I hope the video helped, guys. If it did, give it a thumbs up, subscribe to my channel. I put out new videos all the time, and I'm happy to answer any of your questions. But until next time, I hope you have a good one.